So Mia, why don't you share your screen and walk through how you solve the problem? You can't hear you, you're muted.
Okay, here we go. So the first thing we did was we looked at the graph and we decided that it was a continuous one since there's no open circle. So then we just substituted what was given as x approaches 1/2. So we did negative, wait, not this color, 1 second. Okay. Negative 1/2 plus 2, and then over, and then we substituted 1/2 into the bottom. So 1/2 squared, 1/2 squared plus 1/2, and then plus 1. So after we did that,
Stop right there. Everybody okay with that? Any questions yet? Interrupt if you have a question. Okay, go for it.
Okay, and then after we did that, we started to simplify it. So we saw the numerator first, and we got 3/2. And we got 3/2 because if you put 2/1 and then you have to find a common denominator, and the common denominator would be 2. And then if you add it together, you get 3/2. So then we simplified the bottom, and 1/2 squared, we got 1/4. 1/4 plus 1/2. And then we did plus 1/1. After we did that, we found a common denominator amongst all of them, which for the denominator, the common denominator was 4. So we multiplied 1/2, 1 times 4 and 2 times 4, and then 1/1, 1 times 4 and 1 times 4. And since we did that, we got, on the numerator, we still have 3/2. But on the denominator, we now have 7/4. So 7/4. And then we realized that we couldn't leave it like that because it's like a double fraction. So what you do to solve that is you multiply by the reciprocal of the denominator. So 4/7 on the bottom, and on the top, you have to do the same thing. 4/7. And then the bottom just cancels out to 1. So you can just cross it out like that. And so 3 times 4 is 12, and 7 times 2 is 14. And then you have to simplify it, which equals 6/7. And that's our answer.
So let's take a look. Okay, so everybody got that written down? Yes, okay, so I'll stop sharing for a minute. And let me share again here. Come on. Share. All right, so you got 6/7 as your answer. And if I'm looking at the graph here, this is as x approaches 1/2, right? So 1/2 is right about here. And it looks like it would hit the function like right about there. So yeah, but less than 1/6/7 looks like it's a pretty good answer to me. How does it look to you guys? Yes? Okay, so people who were stuck, where did you get stuck? Talk to me. Now, come on, 2 groups came back and they said that they were iffy about it. So where'd you get stuck? What was bothering you?
My group, we tried the substitution and it didn't look right. So then we tried doing other stuff and that also didn't look right.
What didn't look right about substitution? You don't like, was it the fractions or what?
Well, okay, so we got we went all the way up to where the common denominator and everything. And then we got 1 1/2 over 8/4. And then we simplified that to 1.5 over 2, and that just didn't seem right.
Okay, so I'm seeing two things. Mia got 7 over 4.
Oh yeah, it would be 7 over 4.
It'd be 7 over 4. It should have been 7 over 4, right? Okay, but I'm going to make a very, 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 very strong suggestion. Forget about mixed numbers. Forget about them. They're so difficult to work with. Use improper fractions. So this would be 3/2. See, so 3/2, that's the same thing that Mia had. And then if you had 7 over 4, you would have wound up with the same answer. Everybody okay with that? Is there a question? Forget about mixed numbers. They're worse than decimals. And you know, I'm not a big fan of decimals, you know that, right? All right, let's try. So the second one looks like this. A little bit different because I see some vertical asymptotes here. You have to decide whether that's going to affect your answer or not. Everybody with me? You understand what I'm saying? Okay, let me stop sharing here. And let's, okay, so this is the second problem. I'm just going to talk a little bit about what's going on here. So looking at this graph here, it looks to me like I have a vertical asymptote at x equals 3 and at x equals 4. Can you see that? Yeah, and we know we get vertical asymptotes when the denominator is 0. Are you good with that? So I'm guessing that this can actually be rewritten as x minus 8 divided by x minus 3, x minus 4, because I have a vertical asymptote at x equals 3 and x equals 4, which indicates to me that I would get these two factors in the denominator. Am I making sense here? I'm not getting a real positive vibe here.
Well, it makes a lot of sense. I just didn't know. How did we know we were supposed to do that?
Well, you didn't. I'm just pointing this out to you.
Oh, okay.
Okay, but because what we're really concerned about is the limit as x approaches 2, right?
Mm-hmm.
So at x equals 2, that's right here, I don't really have to worry about anything because the graph is continuous right there at x equals 2. You follow me? The graph kind of, here's x equals 0, and the graph, here's x equals 1, and here's x equals 2, and here's x equals 3, and you see what I'm saying? The graph just kind of continues, right? So I don't really need to worry about there not being a limit here because the graph is continuous at x equals 2. That means I can just use substitution and put the 2 in for x in those 3 spots. Is that helpful at all?
Yeah.
Are you just saying yeah?
Does that tell us anything about our answer? Like, what's the? I guess I just don't understand what the graph is for.
The graph is just basically telling you that you can use substitution without having to do any of this stuff. You don't have to do this because you can just use substitution because the graph is continuous at x equals 2.
And if it wasn't continuous at x equals 2, what would that mean?
Then that would mean that you'd have to do some algebra up here and figure out what's going on, which you're going to find out in the next problem.
Okay.
That work for you?
Yeah.
Okay, great. Let's let me pause the Zoom recording. Okay. Here we go. So the function as an entire function is not continuous because we have these two vertical asymptotes right here at x equals 3 and x equals 4. So you can see if I want to draw this graph, I could start over here and I don't have to lift my pencil from the paper. Well, except that down here, now I have to lift my pencil from the paper to start the other side. You follow what I'm saying here? Okay, so the graph, the function is not continuous. However, all I'm really concerned with is it continuous where x is equal to 2. So here's x equals 2. And as far as I can see, right at that spot, this graph is perfectly fine and continuous over there. You see, I don't have to lift my pencil from the paper there. Are you okay with that? Great, okay. So go ahead, Maria, continue. But you're muted. Okay, good.
Okay. Yeah. So okay. So then what we did was we subbed in for 2.
Mhm.
So then by doing that we got negative. Sorry, 2, just 2.
Okay.
2 minus 8. Sorry, I don't use the whiteboard
Okay, I
very
understand.
often.
2 minus 8.
And then 2 squared.
It's okay. We know what you're saying.
2 squared minus 7 times 2
Uh-huh.
plus 12.
Okay. And what did that turn out to be?
That turned out to be negative 6 at the top.
Uh-huh. Good.
And then here we obviously have to follow PEMDAS. So that's 4. And then this is 14.
Uh-huh.
So then what we did was 4 minus 14, which gives you negative 10.
Good.
And then negative 10 plus this 12 that we left over here gives us 2.
Great. Uh-huh.
But we can't leave it like that. So we simplified and that gave us negative 3.
Negative 3. So let's take a look at it. So you stop sharing now. Let me share again.
Okay.
So it's looking to me like at x equals 2. Yeah, it looks like it crosses the graph right there at negative 3. So that would be my limit right there is negative 3. So the limit as x approaches 2 of this function is negative 3. Right? So you'll find this interesting. I'm going to ask my niece or nephew question again. Who has a niece or a nephew that is getting ready to turn 3? Anybody? No? Who has a niece or nephew less than 3? Okay, so not getting ready to turn 3 quite yet, but pretty soon. Well, maybe in a year or 2. Yes? Yeah. So what you do on their birthday cake is you do this. You put a parentheses around it and a negative sign. See? So it's negative 3, and they're 3 years old for their birthday. Pretty good? I expect to see pictures of these birthday cakes, when they turn that age, and maybe even videos with them crying. No, I'm not that old. I'm not that old. Okay, last problem. Pay close attention to this problem because not only am I seeing a vertical asymptote, I'm also seeing an open circle. And that open circle looks to me like it might be in a troublesome spot. Okay. So I'm going to put you into groups again, different groups. We're just mixing them up like crazy here. Wait, where'd Alex go? Oh, maybe I didn't close the rooms. Okay, let's do it again. Here we go. There you are, Alex. I don't know. Here we go. New rooms. Go.
Wait, can I draw like that? So we figured out that we had to factor. So we had x plus 3 over x plus 3 times x minus 1. Oops.
And how did you decide you had to factor?
It couldn't be substituted because negative 3 plus 3 was 0.
Okay, now let's wait a second here. Keep writing what you got there. Okay. So I'm gonna look at the Stop sharing for just a second, okay? Wait, I think that means that it's gone. Is it gone?
It might be.
It might be gone. No, you think it's still there? Let's find out. Okay, so we'll find out in a second here. So this was a problem. And you said if you substitute in -3, then you would get a 0 up here. Yes, okay. There is not a problem with getting a 0 in the numerator. It's okay to have a 0 in the numerator. It's in the denominator where it causes a problem. So if you substituted -3 into your denominator, you would have gotten -3 squared plus 2 times -3 minus 3. So that's going to be 9 minus 6 minus 3. That's your 0. That's what causes the problem and tells you have to factor. Are you good with that? Okay, let's let you continue here. So I stop sharing, and now you can share again. Oh, it stayed. How about that? Okay, so then what'd you do then?
So then we canceled out these two, and we were left with 1 over x minus 1.
Good.
And then we were able to substitute. Yeah, so we had 1 over -3 minus 1, which just left us with -1/4.
Very good. -1/4. I think that works out wonderful. How do we feel about that, everybody? You feel okay about that? Let's take a look at the graph. Okay, so I think you need to stop. There we go. That's good. So yeah, I mean, when I'm at -3, I can see the graph is not continuous, but that point right there looks like it's about -1/4 on the y value. So pretty good, huh? Not bad. Very good. Well done. Well done. Okay, so I think you guys are kind of getting the hang of this, huh? Do some more practice problems. Always a good idea to do some practice problems. You know. All right, now. Yeah, we can cover some of this. Okay. Polynomials are wonderful because they're generally smooth and continuous. Rational functions have vertical asymptotes or holes. And I know that I told you we were done with trigonometry, but I guess I lied because we still have a little bit of trigonometry we're going to do here. We can find limits. We can find limits for, excuse me, for trigonometric functions, for exponential and logarithmic functions, and composites of those functions. So we can find limits for all sorts of functions. So here is a problem. Whoa. Mia, your eyes just got really wide there. You know, it was like, what? You know, I have to do this. You know, this is very powerful. I told you before, like you can go to when you learn how to do this, you just take this to your parents and you put that in front of them. Say, can you solve this problem? No, you can't solve this problem. So I am going out this weekend, even though you don't want me to. You can't solve this problem. Don't really try that. It won't work. All right. So I have to find the limit as x approaches pi over 2 for the function secant 2x. Well, now they were very kind to make me graph of the function secant 2x. So I'm going to look over here. This is my x-axis. Everybody sees my x-axis right here. And I'm going along the x-axis, and I see that at pi over 2, you see it's marked there at pi over 2. I can see that my function here is continuous there at pi over 2. So I don't really have to worry about it not existing there. I don't have to worry about a hole. I don't have to worry about a vertical asymptote. I can do substitution. Well, if I can do substitution, then I'm just going to take this pi over 2 and put it into my function. So I substitute, I get secant 2 times pi over 2, which is the same thing as secant pi. And I'm thinking, man, that was ages ago. I have no idea what secant pi is, right? But I can pull out my unit circle because Mr. Jenkins says you can use the unit circle. Now I do have to remember my six pack. Remember the six pack? I have sine theta, cosine theta, tangent theta. Then I have cosecant theta, secant theta, and cotangent theta. So I am reminded that secant is the reciprocal of cosine. So secant pi is the same thing as 1 over cosine pi. And if I go to my unit circle, remember the unit circle? Here's 0, here's pi. Well, over here, what is cosine pi? Cosine pi is -1. So I have 1 divided by -1 equals -1. So the limit as x approaches pi over 2 of secant 2x is -1. And again, looking at the graph here, I can see that here is my x-axis. Here is y equals -1. And as my x is approaching pi over 2, my y value is getting really close to -1 from that side and really close to -1 from that side. So the limit as x approaches pi over 2 of secant 2x is -1. Pretty good? Yes, makes sense? All you people with your cameras off, can you give me a thumbs up or something? Or a thumbs down? Or what are some of the other reactions? Applause, party hat, something, you know. Okay. All right. Try this one. Give it a try. I'm going to leave you here. Try this one. Here we go. We'll talk about this problem. So Magic Bowl is going to ask Maria, is the function continuous?
Yes.
Looks like it to me. What's the domain of the cosine function, Maria? Do you remember the domain of the cosine function? No? Who remembers the domain of the cosine function? Nobody remembers the domain. Mia, what?
Is it negative infinity to positive infinity?
It is all real numbers. Remember the cosine function? It just goes like this. It's gonna go up and down and up and down, and it's gonna do that forever on both sides. All real numbers. Okay, so yes, cosine function is continuous. So then if it's continuous, that means I can just take this pi over 6 and substitute it right in there for x. So cosine pi over 6. I happen to remember that that is equal to radical 3 over 2. So that should be my limit. Let's see. Radical 3 over 2. How about that? Pretty good? Questions? Okay. How about, I'm going to give you one more. Oh, this one's pretty easy. You should be able to do this one. I'm saying it's easy because we kind of just did it a second ago. Well, no, we did pi over 6, not pi over 2. This is different. So let's go to the magic, well, we're done? We're okay? Okay, let's go to the magic bowl. Who gets to answer this problem? Crystal, what did you get as your answer?
Somehow I knew you were gonna call me for this one, Mr. Jenkins.
But you know something, Crystal, there's 9, there's 10 people on this Zoom call right now other than me, and all 10 of them knew that I was gonna call them. Right, but then I didn't, I only called you. All right, go ahead. What'd you get?
So I'm not completely sure how to do this one. So
Okay.
it's continuous. So it's continuous. So it's gonna be -2
Okay,
cosine, and then pi in the parentheses pi over 2.
very good. Okay, so what is cosine pi over 2?
That's a good question.
So here, let's make a unit circle. You remember this is 0 and 2 pi, right?
Yeah.
And this is pi over here because it's halfway around, right?
Mm-hmm.
Then this would be pi over 2 because it's halfway to pi, right?
Yeah.
So then down here is 3 pi over 2. I may as well put that in there. So here's the point. The x value pi over 2. Well, no, here's pi over 2, right?
Right.
What are the coordinates of that point?
2, 0.
No, forget about the 2. What are the coordinates of this point on the unit circle?
Oh, is it 1, 0?
What's the x value and what's the y value?
The x is 0.
Uh-huh.
Oh, and the y is 1.
Very good. Okay. And it's cosine x or y?
Cosine is x, I believe.
So then what is cosine pi over 2?
It is 0,
So what is -2 times 0?
0.
So what is the limit as x approaches pi over 2 of -2 cosine x?
0.
There you go. Pretty good? Does it make sense? Everybody good with this? All right, then you need to do practice problems. And then, so we're gonna stop, and then on next week, whatever the day it's gonna be, Monday, yeah, then we're gonna talk about right-hand limits and left-hand limits. And that's it. Okay? Eat early lunch, get an extra 7 minutes for lunch. We'll see you later. Well done.
You.
Thank you.
You're welcome. Good
Thank
job.
you.